Now see this question. This is asked in GATE 1997. The number of equivalence relations on this set 1, 2, 3, 4 is, which means if we have a set containing 4 elements, then how many equivalence relations are possible? Till now we have counted the number of reflexive relations, transitive relations, asymmetric, antisymmetric. All these we counted, but then we didn't count the number of equivalence relations. The reason is it is not very easy. There is no simple formula for this. You have to work a lot for that. So that is why I didn't say it, but then just remember 2 answers. So this is the only thing you might have to remember. If we have a set with 3 elements, then the number of equivalence relations possible is 5, and if we have set with 4 elements, then the number of equivalence relations possible is 15. If you have even more than that, the number will be very heavy, very big, and it will be difficult to compute also. Even though the number of equivalence relations and also the number of partitions. So what is a partition? We shall see later. There is a concept called partitions. So partition is nothing but the number of ways in which you can divide a set in such a way that no 2 parts are having anything in common. For example, if you have 1, 2, 3, 4, you can divide them in such a way that 1 is in one partition, 2, 3, 4 are in other partition, or you can put 1, 2, 3, 4 in 4 different partitions. That is called partition, right? So the number of equivalence relations and the number of partitions on a set both are same. Okay, but anyway, even after knowing that the number of equivalence relations can be computed by finding out the number of partitions, it is difficult to find out the number of partitions. Even if you are able to transform a problem, still that is NP complete problem, right? Therefore, finding out the number of equivalence relations is not very easy. So just remember these 2 answers. For a set containing 3 elements, it is 5. For a set containing 4 elements, it is 15. Okay. And next one is asked in GATE 1998. Suppose capital A is a finite set with n elements, then the number of elements in the smallest and largest equivalence relation is. We already know that if a relation has to be equivalence, it has to be reflexive, and the smallest reflexive will contain n elements. And if you put all the diagonal elements in a set, then it is going to be reflexive, symmetric, as well as transitive. We have already seen it, right? Therefore, the smallest reflexive or the smallest equivalence relation will contain n elements. And what about the largest equivalence relation? It will contain n square, which means if you take A cross A, that is nothing but a equivalence relation. We have already seen it. And the next one is, if you have R1 and R2 are 2 equivalence relations, then what can you say about it? R1 union R2, R1 intersection R2. Are they going to be equivalence or not? That is what they are asking. So first of all, let's solve it. Now, if R1 union R2 has to be equivalent, then see, R1 union R2 has to be reflexive, symmetric, and transitive, right? Let's solve this one first. We know that R1 is reflexive and R2 is reflexive. How? Because they are already given as equivalence relations. Therefore, definitely diagonal elements, all the diagonal elements are present both in R1 and R2. When I take the union, definitely we are going to get the diagonal elements, and so it is reflexive. What about symmetric? So R1 is symmetric and R2 is symmetric. Therefore, if there is an element of type A comma B in either R1 or R2, definitely there will be an element B comma A along with A comma B. Therefore, whenever you take the union, the pair is going to come out, and so it is symmetric. And also we have already seen that symmetric relations are closed under union operation, isn't it? So it is going to be reflexive and symmetric. What about transitive? Need not be. The reason is we have already seen that transitive relations are not closed under this union operation. So if you want an example, I can give you an example. Let us say A equal to 1 comma 2 comma 3. Then let us assume that R1 is equal to 1 comma 1, 2 comma 2, 3 comma 3, and then we have elements like this. Let me put 1 comma 2 and 2 comma 1, right? And then R2 is having elements 1 1, 2 2, 3 3, and then let me put 2 comma 3 and 3 comma 2. Now if you check it, R1 is equivalence relation and R2 is equivalence relation because it is reflexive and it is symmetric and also it is transitive. You can check this. It is transitive because it is containing 1 2 2 1 and so 1 1 is present, and then 2 1 1 2 and so 2 2 is present. On the same grounds, it is reflexive, transitive and also symmetric. So we have R1 and R2 both are equivalent relations. Now when you take union of this, then the relation is not going to be equivalent because it fails to be transitive. The reason is simple. Now after taking the union, we'll get 1 2 and 2 3. Both of them will be present. When 1 2 and 2 3 are present, then there should be 1 3, but 1 3 is not present in this, and so it is not transitive, and hence it cannot be equivalent. Therefore, since transitive relations fail to be closed under union, we cannot say that R1 union R2 is equivalent. Therefore, it is false. Then what about intersection? Intersection, definitely, if you take two reflexive relations, definitely the intersection is reflexive because all the diagonal elements are going to be present. And if you take two symmetric relations, the intersection is going to be symmetric because, if you get a pair A comma B, then definitely A comma B comma B comma A will be present in both the relations because they are already symmetric, and so they are symmetric. And what about transitive? That is what we should decide here. So will the intersection of two transitive relations be transitive? Now let's think about it. When will it not be transitive? If you get A comma B and B comma A, and if you don't get A comma C, like this, if you get A comma B and B comma A into the intersection, B comma C into the intersection, and if you don't get A comma C, then it fails to be transitive. But then if you are getting A comma B and B comma C into this intersection, definitely these two should be present in both R1 and R2. And when these two are present in R1, let's say R1, now since R1 is already transitive, R1 will also contain A comma C. And similarly, since these two are present in R2 and R2 is transitive, R2 will also contain A comma C. Therefore, along with these two, we'll get A comma C also into the relation, that intersection. Therefore, we can say that it is going to be transitive, and so intersection of two equivalence relations is going to be equivalence relation. Got it? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have, you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.